Today we're going to take a look at 3-2, solving linear equations by graphing. So we've graphed equations, and now we're going to look at how to solve them using that graph, and we're going to estimate some solutions also by graphing. So some vocab that we need to be aware of. A linear function is just a function where the graph is a line. Okay. The simplest linear function is right here. It's f of x equals x. The f of x is just function notation. We could just think of that as y. Okay, it's the same as y equals x, but when we use the term function, we're going to use this f of x, and we've looked at that already some, but just so we're aware. The parent function is like the simplest of the functions. Okay, so that's right here. Again, f of x equals x is the parent function. And then we have a family of graphs. That's a group of graphs with one or more similar characteristics. And so we'll talk about those. The parent function, again, f of x equals x, and it goes to the origin. It's a line. Its domain, so the x values, those are all real numbers. Its range is the y values, and it's all real numbers because it goes forever in both directions. The solution, or root, so we need to understand that a root is a solution. So same thing. Of an equation is any value that makes the equation true. So any value that makes an equation true is a root. Okay? You can find the root of an equation by graphing its function. To write the related function for an equation, you replace 0 with f of x. So if we have f of x equals 2x minus 8, we replace that f of x, or y, with 0, and then solve. Okay? And we're going to solve by graphing. All right? The values of x for which f of x equals 0 are called zeros. Another word for solution or root. So roots, solutions, zeros, and you may also recognize that this is the x-intercept, okay? The x-intercept. Okay, so all of those are the same thing, okay? X-intercept, roots, zeros, solutions, all the same thing, okay? So the x-intercept here is 4. The solution here, 4. The root, 4. The 0, 4. All the same thing. So to solve each equation, so first let's look at how to solve it algebraically. We would add 2 to both sides, we would multiply both sides by 3, and we get x equals 6, okay? If we were to solve this equation by graphing, so this second one by graphing, what we would do is we would find the related function. To find the related function, that means we need to get 0 on one side and everything else on the left side, okay? So we end up with, we add 2 to both sides, and we have f of x equals 3x plus 3. And then we can just make a table. Okay, we can make a table. We just pick some random x's. We get some y's because of that. And you basically do that until you get a y that's 0, and that's where the x-intercept is. So that x is the solution. All right. So let's take a look at these two right here. Go ahead and pause the video. Try 1a and 1b. I'll give you answers when you get back, and you can check those. And if you don't get the same thing I get, then you can let me know. But and to be honest, guys, you can solve these algebraically or graphically. I don't care which. But we need to understand that when we graph them, the answer that we're getting is that x-intercept. So pause the video here and get some answers. Okay, so here are the two answers I got. The solutions I got were x equals negative 15 for this one, and x equals 2.4. Again, I know I've been on you guys about decimals, but the problem had a decimal in it, so a decimal can be part of the answer. That's no problem there. If you solved it by graphing, great. If you solved it algebraically, also fine. Just need to understand that that solution is the x-intercept, okay? Let's look at another one up here. Down here, sorry. So to solve this algebraically, this is a no solution problem. We would end up with 3x, you keep working, at the bottom we end up with 6 equals 0. The related function then is f of x equals 6. And there is no root. Okay, there is no root. Since f of x is always 6, this equation has no solution. If we were to graph that equation, what would happen is we would go up here to 6, and we would put a line. This function, as a graph, looks like this. Since the solution is where it crosses the x-axis, and that one is never going to cross the x-axis, it's no solution. Okay? Because the solution is where it crosses this axis. So let's take a look here. We have 2x minus 4 equals 2x minus 6. Again, you solve this by graphing. You get it equal to 0. So we have that. Then we replace 0 with f of x, okay? And then that's this horizontal line, so there is no solution. So let's take a look at these two. Here, we would get this equals 0, subtract 4x from both sides, subtract 3 from both sides, and we end up with 0 equals negative 8. So f of x equals negative 8, so that's no solution. Okay? Here, same kind of thing, add 3x to both sides, we get 2 equals 6, subtract both sides by 2 and get 0 equals 4. Again, no solution. All right? On this next problem, we're looking at a real-world example of estimating solutions. And a graph might only provide an estimate, and it says that, but then we can use algebra to check our answer to find an exact solution. Okay, so let's take a look here. We have an amusement park. We have Emily going to a carnival. The function is m equals 20 minus 0.75 r. That represents the amount of money she has left after r rides, right? So then it says find the 0 of this function, describe what this value means in the context, and the description is important. So we have this function, we put 0 in for r, and we find out, you know, she has $20 left. We put 5 in for r, and we find out she has $16.25 left. And so then the graph appears to intersect the r-axis, which is the x-axis, at about 27. Okay, so at about 27. We do the algebra to check it, and we get 26 2/3. Now you can't ride 2/3 of a ride. That doesn't make any sense. And we can't round up in this instance because she doesn't have enough money to ride up. So the answer is then 26. Okay? So let's take a look at this one right here. Antoine's class is selling candy to raise money for a class trip. They paid $45 for the candy, and they're selling each candy bar for $1.50. This function here represents their profit, y, when they sell x candy bars. Find the 0 and describe what it means in the context of this situation. So you could sketch this out on a graph pretty simply. So we're going to graph this, and we are going to, this is kind of a tough graph to do a little bit because we have to understand a couple things. We have to understand that because they have negative money when they start, and again, your graph might look different than mine, and that's fine. But what I'm going to do is I'm going to go in here and I'm going to say, all right, so they started at negative $45. We'll say 10, 20, 30, 40, and that would be 45. So they're right here when they start at negative 45, okay? And these were by tens. So this is obviously, the y-axis is going to be how much money they had. The x-axis is going to be candy sold, okay? Candy bars sold. And you can count that off however you want. I'm going to do those by tens also. 10, 20, 30, 40, 50. We'll do those by fives actually. 5, 10, 20, 5, 10, 15, 20, 25, 30, 35, 40. So these are by fives. Okay. And again, if your graph is different than mine, that's fine. Just as long as the numbers kind of match up. So then I'm going to pick a couple values. I know that we started at negative $45. So that one's good to go. And then I'm going to pick a couple values, let's say for candy, and then money, and if you want to make it simpler, this is just x and y. So when they sell 5 candy bars, okay, so 5 times $1.50 is what, right? So that's $7.50, and then $7.50 minus 45. And this is when it's not a bad time to use your calculator, so you don't mess up these kind of numbers. So we get negative 37.50. Okay. So at 5 right here, I'm going to go down and I'm going to put a point. Okay. And then I have 2 points, and really to estimate it graphically, that's probably enough. Okay. Because from 2 points I can make a line, and I can say, all right, it looks like based on my line, it's going to happen around 20 something. Okay, now, and if you had graph paper, it would be better because we're going to see here in a second that my estimation is off. Okay, and that's fine. Your estimation can be off. We want to check it algebraically. So how do we check it algebraically? Well, we're going to take 0 for y because we want to know when they break even. Okay, when the 0, the description of what that means in context, that's the break even point. Okay, we want to know when they broke even. All right, and so to do that, we're just going to make the y value 0. And I'm going to solve this algebraically. Add 45 to both sides and divide both sides by 1.5. And hopefully you got 30 candy bars. Okay? Hopefully this stuff seemed pretty simple. What I'd like for you to do is I'd like for you to try solving these 9 questions. Try solving them by graphing and then checking your work algebraically, okay? And we'll talk in class about why it's important to understand a graphic solution as well as an algebraic solution. Try those, and I'll see you tomorrow. Bye.